Okay, so now I'm going to talk about load factor. So load factor is the ratio of a customer's average power demand to its peak demand. So it's a good way for us to characterize the cost of providing power to a customer. It is misleading if we only use average power, because the time that a user uses the power is also an important factor, and the magnitude at any given time is also important. So we need to consider that. For domestic customer, TNB does not concern too much because our consumption is low relative to industrial and commercial users. So this applies to them, where TNB needs to consider the time they use the most amount of power. Okay, so here is the concept of maximum demand that you usually see in power system or power analysis topics. Okay, so load factor, the equation is simple. You just have the average power divided by peak power, and then you turn it into a form of percentage. Okay, so the average power usually it's calculated monthly, every month. So we have kilowatt hour for that month. So that's the average power. And then the peak power is the maximum demand with times 24 hours and times 30 days. All right. Okay, so let's see a sample case. So we have two scenarios. Scenario one, a customer that has a peak demand of 100 kilowatt. Okay, so the peak demand is only 100 kilowatt and uses 876,000 kilowatt hour per year, right? So it has this customer has a load factor of 100%. That means it only uses constant amount of power, 100 kilowatt, for every hour throughout the year. Okay, so basically, if we turn it into a graph, it's going to have to be a graph with a flat curve, a flat line, 100 kilowatt throughout the year. Okay, then we have scenario two, another customer, it also uses a total energy of 876,000 kilowatt hour per year. That means it used 100 kilowatt for 8,760 hours per year, the total amount. But it has a peak demand of 200 kilowatt. So when we divide, we have a load factor of 50%, right? So the average is still 100, but the peak is 200. So 100 divided by 200, we get 50%. So for scenario 2, the utility would need twice as much as generation capacity, transmission and distribution capacity to serve the customer. Okay, even though they use the same amount of energy in the end. So the rate of structure or how they charge these two customers must be different, because the way they use energy is different. Okay, if we use standard billing where we count based on the amount of energy, so the amount of dollar per kilowatt hour or ringgit per kilowatt hour cannot differentiate these two customers. So basically, if we use the amount of energy, we charge, if TNB charge based on the amount of energy, then the bill for these two customers is going to be the same. But the way they use the energy is different. So TNB introduces what we call as demand charges to compensate for this difference. Okay, to illustrate, let's see this figure here. Okay, we make it simple. This is a daily usage of power, right? So it fluctuates throughout the day, sometimes high, sometimes low, but it has a peak value. Let's say we have a peak value of, this one is a simple example, 200, for example, 200 megawatt or 200 kilowatt at 2 o'clock. Only at this time it uses this amount of power or energy. So that we draw a line, horizontal line. So this one is what we call as the peak value. But then the average value is somewhere here. because we consider that it fluctuates, right? Sometimes it goes low, sometimes it goes high. So the average value is somewhere around here. Okay, I don't calculate it exactly, but we just assume. But because the peak value is here, TNB needs to prepare the generation and prepare the capacity throughout the day, even though it's only going to be used at this time. So we have the shaded area here. This is the amount of capacity that TNB needs to prepare, even though it's only going to be used for a short time here and maybe here. But the shaded area represent, that means even though they only use short time, but TNB needs to prepare for the whole day. Okay, so the same principle goes for the whole year. So one whole year, maybe they use the power, maximum power or maximum demand a few times, but TNB needs to prepare throughout the year. So that is why TNB needs to charge the consumer or the user who has this peak value, different from a customer who has a lower energy consumption or lower demand. Okay, so when we talk about here in the previous slide, we see the term demand shifting. Okay, so demand shifting is basically TNB wants to encourage the user to shift this time. Instead of using power at this time, if possible, they want the user to shift the time to use it at the time when they have low power usage. For example, this part here, if possible, they want to encourage the user to shift this usage during this time. So that way they can reduce the peak, and TNB can reduce the capacity they need to prepare. So that's the basics of maximum demand. If the industry or if the customer cannot shift, then TNB need to charge, because TNB need to prepare more, even though it's going to be used for a short time. Right? Okay. So this is a straightforward example of how TNB calculates the bill based on maximum demand. So we have two customers. Let's say each customer uses total energy is 100,000 kilowatt hour. Now remember, when I talk about power and energy, power is just watts or kilowatts. Energy is power multiplied with time. So when we have kilowatt multiplied by hour, then we get total energy. Okay, so this is 100,000 kilowatt hour, so energy per month. But customer A has a load factor of 15%, customer B has a load factor of 60%. So that means for customer A, the average divide by peak is big. The peak value is large compared to the average value. That's why you have a low load factor. Okay, so first we have a rate structure that charge based on the amount of energy used, and then we have a maximum demand based on the magnitude of the peak power. Okay, so here we just take example of 30 ringgit per kilowatt peak of demand per month, right? Okay, so the maximum demand here, when we calculate using the equation just now, so the load factor for customer is 15%, so we convert it into a percent, divide by 100 to get in a point form, and we get the maximum demand for customer A is 925.9 kilowatt. That's the peak power it used throughout the month. For customer B, the peak power only 231.5 kilowatt. So a huge difference in terms of the peak power that is used throughout the month by these two customers. So of course, first TNB is going to charge the total energy. Okay, the total energy is going to be the same for these two customers, but now it adds another extra charge for preparing the peak power, for preparing the extra capacity. Okay, so now for customer A, it needs to pay 30 ringgit 30 cent times with the total peak power 925. So it needs to pay total of 64,500 ringgit. Whereas for customer B, it needs to pay only 43,000. So a huge difference. This in essence is because TNB wants to encourage customer A to reduce the maximum demand or to even out their electricity usage so it does not peak like so high at any given time. Okay, so this is the fundamental of load factor.